Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Hello everyone, good morning, good afternoon. Today we are coming with the workshop titled Using En-ROAD's Tools for Simulation the Climate Action and Climate Change. This workshop is presented by Professor Dr. Hüseyin Gökçekuş, Dr. Yusuf Kasım, and me, Farhad Bolouri. But before beginning and before starting the workshop, we want to ask you to go and complete a questionnaire that is in the Google form. I share as a comment the Google form link in YouTube, and now I will share the link in the YouTube. And yes. I will share the link. I will share the link in the our Google Meet room as a comment in the YouTube, and I want you to go and answer the questionnaire until 10 minutes. We wait for you because this is pre-workshop questionnaire, and after workshop we have the post-workshop questionnaire. Some of the questions will be same, but don't worry, it is not about grade and depend on the certificate. It is just to see how is your awareness and everything about the climate change until now, before the workshop. Because of that, I am sharing the Google Meet link with you as a comment here and in Google Meet. Please answer the questionnaire. Thank you so much. And here you can see the link too. We are waiting until 10 minutes, until 11:33 for your answers. Bakın ben oradan çıkınca sıkıntı nasıl olur? Tamam. Please everybody answer the question. You are answering? Yes, we are waiting for you.
You have to answer.
Because we have pre and past. You see the link. Just type it in your phone. Because it shows how the workshop affects on your awareness about the climate change. This is. Oh, you want the link? Okay. Yes.
Where is the link?
İşte herkes
Any problem?
we want to
You are
see
answering? Okay.
the link is this. Please share the link if you type in the group, our WhatsApp group, to your friends. Because I want to do something. Yes. Yes, the link. Just go to link. Yes. But I'm doing something. What's your problem? It does not working? No, it's working. What?
I couldn't find the links. Yeah.
But some of them
You wrote?
answering.
You wrote the link exactly?
Someone shared it in the WhatsApp group.
Yes.
Huh,
Anybody
yes.
can go to this link.
Ladies, is it
Please.
possible to send the link by using WhatsApp group, our WhatsApp group? Who can help?
No, I don't access to Üzüm now.
She is sending WhatsApp.
Post. Delete.
Share with our professor.
Yes, hocam. Hocam benim şeyim de yok. Hocam şeyin gönderdik bunun bu recording. Çünkü bana söyledi maili her şeyi kapat.
Who complete? Anyone complete?
Okay, they have 5 minutes.
Okay, we have more time. First try to enter to the program.
Okay. Bir yerden ses. Şimdi yazırım ben. We are waiting for your answers. Evet. Neler yazmış?
Ben Hüseyin Hoca'ya verecek misiniz? Yine şu an.
Hocam
Verecek misiniz?
şu an
Betül Şener.
hocam okuyorum. Çoklu bir şeyler yazmış.
Hı.
Son şu an sorun nedir? Yayınladınız. Şu an Hüseyin Hoca'yı davet edecek.
Yes, yes. Evet.
Evet. Sizden görüntü aldılar.
Hı hı. Benim şeyim için mesela.
Şey olsun hocam, ben bir davet yapmışsa. Buradan da ses açmam lazım.
Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi. Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, Sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Kahvede misiniz ya? Allah aşkına.
Did you send? Yes, send.
Perfect.
Because after workshop we have another one with comparative
Send us your
translation.
questions. Okay. Answer. Peki.
Şimdi tamamdır.
Bağla beni. Yani,
Bağlısınız hocam.
hayır, PowerPoint.
Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Yazmalarım lazım hocam sizin.
Gerçekten.
Her şey tamamdır.
Sunumu isterim. Ha.
Sunum. Şimdi görürler sizin sunumu. Tamam. Hocam siz başlayabilirsiniz.
Hı?
Başlayabilirsiniz.
Sonra istersen.
Evet, başlayın yazmış.
Okay. Good morning. I would like to say welcome you all to our workshop, En-ROADS Climate Action Simulation. We will talk about the climate change. First of all, as an introduction, and later on, we will talk about the program. This simulation is very important. It's practiced by the MIT, the famous university worldwide. And let's come to my presentation. This simulation developed by Climate Interactive, MIT Management, and Climate Change Initiative. This is our agenda today. Let's start with what is climate change question. Climate change refers to long-term shifts in temperatures and weather patterns. These shifts may be natural. Human activities have been the main driver of climate change, primarily due to the burning of fossil fuels like coal, oil, and gas, which produces heat-trapping gases. This is named as greenhouse gas emission. This is the figure, show us the mechanism of the greenhouse effect.
StreamYard'daki şey için. Şimdi paylaşabilirim.
Okay. The solar radiation passes through the clear atmosphere. Most radiation is absorbed by the Earth's surface and warms it. Some solar radiation is reflected by the Earth and the atmosphere. Some of the infrared radiation passes through the atmosphere, and some is absorbed and re-emitted in all molecules. The effect of this is to warm the Earth's surface and the lower atmosphere. Infrared radiation is emitted from the Earth's surface. This is another figure to show us natural greenhouse effect and human enhanced greenhouse effect. Climate action simulation, let's say something about our simulation. Global climate simulator allows users to explore the impact of roughly policies such as electrifying transport, pricing carbon, and improving agricultural practices on hundreds of factors like energy prices, temperature, air quality, and sea level rise. Climate action simulation is a group role-playing game to explore solutions for mitigating climate change. Real data, computer simulator, mock UN summit. How the climate action simulation game works. Global leaders from sectors across businesses, government, and civil society gather to negotiate a climate solutions plan to limit global warming to less than 2 degrees centigrade and ideally 1.5 degrees centigrade above pre-industrial levels. We will use and roads a cutting-edge simulation model to test climate solutions and generate climate scenarios for the future. Let's briefly review the science and what's at stake. Is it okay?
Belki de bir internet problem var. Ama siz devam edin.
Okay.
Ben buradan bakarım.
Atmospheric carbon dioxide is higher than any time in the last 800,000 years. And levels are increasing faster than any time in millions of years. This is another figure to show us global temperature changing from pre-industrial. This is also show us carbon dioxide emissions by sources. The main source, as you see, coal, oil, gas, and other. This is another figure, total annual global greenhouse gas emissions by gases. As you see, the main source is carbon dioxide from fossil fuels, 68%. And the other carbon dioxide source comes from land use and forestry, and methane, 18%, and N2O, 5%, and F gases, 2%. Baseline scenario, temperature change. Our climate goes 1.5 degrees centigrade to 2 degrees centigrade. What would 3+ degrees centigrade of warming mean? Arctic Sea ice is gone in 2 out of every 3 summers. 50% of insect species lose. More than 50% of their habitats range. And drought, 11 months longer. Area burned by summer wildfires in Mediterranean doubles. Another problem, sea level rise. You can see the flat risk map. This is an example from Hanoi, from Vietnam. Think about 3.6 degrees centigrade increase the temperature. What will happen? Flat risk from sea level rise by 2100. In the same area, if we look at again, from Vietnam to Hanoi, 3.6 degrees centigrade, temperature increase, Flood risk from sea level rise over next few centuries. This is Dubai today. But what will happen? Together with 3 degrees centigrade warming. As you see, like lake, huh? Climate-related disaster cost the world $6,650 billion between 2016 and 2018. Damages associated with global warming could total over $54 trillion by the time we reach 1.5 degrees centigrade. Welcome to UN Climate Action Summit. Opening remarks by completed by opening remarks by UN Secretary General Antonio Guterres and UNFCCC Executive Secretary Patricia Espinosa. Our goal today, limit global warming to less than 2 degrees centigrade and as close to 1.5 degrees centigrade as possible above pre-industrial levels. Let's look at conventional energy. Largest energy suppliers in the world: coal, oil, natural gas, nuclear, and electric utilities. Clean technology, global leaders in clean technology: wind, solar, and other renewable energy sources. Energy storage, electric vessels, energy efficiency, green buildings, technological carbon removal, new energy for the future. Industry and commerce, largest energy consuming corporations, automakers, airlines, shipping, and freight, other transport, construction, industrial machinery, manufacturing, consumer products, and high technology. Land, agriculture, and forestry, global alliance of food and agricultural companies, large landowners and farmer advocacy groups, logging companies, land conservation groups. Climate justice hubs, leading environmental non-profits, climate justice organizations, grassroots and youth movement, global citizens from communities harmed by climate change, world governments, government leaders from around the world representing developed countries, EU, USA, Canada, etc., rapidly developing countries, China, India, etc., and small island nations. Looking ahead, we have the tools. Solar and wind are growing and getting cheaper. Corporations are investing in clean technology. Countries and states are stepping up. The general public is becoming more educated and engaged. Companies are starting to take action. There are some examples. Clothing brand H&M has promised to double its energy efficiency by 2030. Over 260 of the world's largest companies have committed to using 100% renewable electricity by 2050, with an average target date of 2028. Microsoft has pledged to be carbon negative by 2030, removing more carbon than it emits. Carbon prices are being enacted around the world. Current or planned carbon pricing covers 22% of global emissions. 80 plus jurisdictions, regional, national, or subnational, have implemented or are considering carbon prices. The world as we have created, it is a process of our thinking. It cannot be changed without changing our thinking. It's said by Albert Einstein. And Margaret Mead said that never doubt that a small group of truthful, committed citizens can change the world. Indeed, it is the only thing that ever has. Global climate strikes, September 2019, over 7 million people in 185 countries. Impacts at different levels of warming. Let's see 1.5 degrees centigrade of warming, what will happen? Increase of 3 up to 4.5 degrees centigrade in extreme temperatures in some regions. 70% of coral reefs bleached, drought 2 months longer, and 13% of people face severe heat waves at least every 5 years. Think about the temperature will increase 2 degrees centigrade of warming. Okay, what will happen? Risk of river flooding more than doubles. 90% of coral reefs bleached, drought 4 months longer. Over 50% of world's population exposed to lethal heat for more than 20 days per year. 3 degrees centigrade of warming. Arctic sea ice is going to out of every 3 summers. 50% of insects species lose more than 50% of their habitat range. Drought 11 months longer. Area burned by summer wildfires in Mediterranean doubles. This is the worst scenario. 4+ degrees centigrade of warming. Sea level rise this century, approximately 1.2 meters. Unbelievable. All the coastlines will be under water. More than 2/3 of glaciers in the Himalaya mountains melted. 1 in 6 species could go extinct, and 3/4 of world population exposed to lethal heat for more than 20 days per year. Climate crisis. Not all countries face the same level of responsibility regarding the climate crisis. The biggest polluters need to take action to reduce their carbon emissions, but also to offset their carbon footprint by supporting environmental projects around the world. Developed countries, contrarily, the highest rates of energy consumption are found in the developed countries. And this is a major cause of global greenhouse gases. Developed countries become rich nations due to exploring and utilizing more energy in their industrial activities that is also higher than developing nations. 10 countries are contributing most to climate change. You can see the amounts. The first country is China, United States, India, Russia, Japan, Germany, Iran, South Korea, Saudi Arabia, and Indonesia. Let's look at the amounts. China means with more than 10,065 million tons of carbon dioxide released. United States with 5,416 million tons of carbon dioxide. India with 2,654 million tons of carbon dioxide, and Russia, Japan, Germany, Iran, South Korea, Saudi Arabia, and Indonesia comes through. This is calculate 2019. This is a reference. taken 2019. It's changing time by time. Because of why I'm saying this, because of I remember the first was USA, but now China get the championship. Right? China is the champion country now. Yeah, yes, 2 times, double. And this is my last page for my presentation, climate action simulation and rules. The climate action simulation combines an interactive computer model and rules with a role play in which participants make decisions. Therefore, my PhD student, Farhad Bolouri, will present about En-ROAD simulation tool that help us to predict or project the future of our world and the influence of climate change on our world. Thank you so much. Let's close the.
Thank you so much, Professor, and hello to everyone. I want to, yes, here I must stop my sharing because we are doing 2 things. Okay, now I want to present how to work with En-ROADs because we have a tool for modeling the climate change. But I am sharing my screen. It is a Google Meet sharing screen, and in there I will share my PowerPoint because we have attenders, more than 225 attenders from Google Meet, and because first we announce it, I share my Google Meet screen, and after that I share with you the PowerPoint and website that I will work with it. It is a En-ROAD tool. Yes, I don't know you see my screen or not. So here I must do the same, I think.
They can see.
In YouTube, you can see my screen. No, not in Google Meet. I mean in stream. In stream, because okay, we will wait because we are working in 2 online system in the meantime, Google Meet and Stream of the university. In both of them, it must be shared. 1 minute, I stop sharing here. Here I share my screen. Okay, I shared. Which one I shared? Okay. I think now you can see my screen. Yes? Yes, exactly. Now I must share here my screen too. As I said, because we are sharing in 2 programs, we must share in 2 places. Okay. Okay. Now you can see, and I put these ones here. There's no problem. Okay, I will present from here. Yes. Yes, as Professor said previously, this is a climate action simulation prepared by Professor Dr. Hüseyin Gökçekuş, Associate Professor Dr. Hüseyin Kasım, and me, Farhad Bolouri. I'm a volunteer for En-ROADS. Professor said what is En-ROADS developed but where. But Climate Interactive that simulated by MIT University. Nowadays they have more than 582 ambassadors from more than 60 countries. And what we do, we learn something from them, and we try to do in some workshops and others for another students and people in the world. They did it and they do it in USA for their policymakers, for Congress, for the presidents they present. But now today we want to present for you as our friends. Okay. What is the En-ROADS? What is the software? In the model, I will say to you, but here a little introduction to it. En-ROADS is a system dynamics model, high-order nonlinear differential equation model. I will say in the remain what is the system dynamics. It has been developed for the past 7 years, and this is for 2020. Now we can say it developed for past 9-10 years. And the last one is very important. By every your click on the En-ROADS, I will show you the dashboard. The results calculated with more than 14,000 equations in per second. It is very important because the models we use in our papers or another research are very limited. But because in here so many scientists, so many universities are doing it, they have more than 14,000 equations. Yes, it is the system dynamics. If you ask me what is the system dynamics, in a very simple way, I can say this one. For example, and I must share that this model based on CO2 emission. You know, the most important thing for climate change is CO2. Professor had in his presentation slides, you see with the CO2, the temperature of the Earth increased. So if you want to see what is the system dynamics is this. You have a stock here, you have some inflow, here is emissions, and you have some outflow, here is net removes. When you minus the emission, the net removals from your emissions, you have what CO2 you have in your stock, or here your stock is atmosphere. For the other thing I want to share. Okay, here you see the En-ROADS core structure. It is very limited part of it. We said it is 14,000 formulas. It is a little part of it. You have, for example, energy CO2 emissions, land use CO2, CO2 removal, other greenhouse gases, for example, methanes, NO2 and others. They come to total greenhouse gases, and in the end it affects on the temperature, and it affects on the impacts that we will see nearly in the model. But for example, for energy CO2 emission, we have what things affect on it. Yes, as you know, population, consumption, energy intensity, carbon intensity, and all affect on the energy CO2 emission. What I want here, yes, I want to say this one after model, but okay, now I will say what is the why they use system dynamics? Because system dynamics can model the delays, because we have always delays. For example, when you go to bathroom, you open the hot water, but it is very hot. After that, you decrease it, and this time it is very cold. You do this so many times. In the end, you see the water is about 30 degrees, and you are stable with it. You are comfortable with it. In the industry, you have the same. When R&D, you know, research and development in a factory, they said they want a new technology. it takes some years to become a product. For example, here they have a new technology in R&D. They said, okay, we want this technology in commercial ready. It takes more than 12 years in average. After that, they said, okay, this is a new tech in capacity development. To becoming this new capacity in the development to construction, it takes 2 years. And after that, when they want to new technology capacity in use, it takes 5 years. So when they want to do it in fossil fuel capacity in use and reduce it, it takes more than 30 years. Here it is in white place, you couldn't see. Yes, it takes more than 30 years. But before this slide, I want to go to model because I want to show the other slides on the model. I must here. When you want to use the En-ROADS, just type En-ROADS in the Google. You will go, here is their website, I show you. Yes, here is their website. Here, for example, is about them. You can go and see their materials, their staff. Here you can see their ambassadors and others. Yes, here their work. En-ROADS. C-ROAD is modeling for the regions of world, 5 regions, Asia and others. In another workshop, we can show you this one, but En-ROADS is for whole world. And yes, here you can see the materials, ambassadors, you can see the ambassador in different countries. Here you can become an ambassador or climate leader training. This is their website. Up here or up here directly, you can go to En-ROADS modeling. I will share this link with you now because you will model your own and you will share with us in the end. Post workshop, one of the questions is share your sharing your own model with us. I shared in everywhere the link of this model. Yes, when you come, this is the En-ROADS. Today we want, after this introduction, we want to work these. Here you can change the language. I know we have some Turkish or Arabic people here. You can use own, for example, English. Here you will some dashboards for reset your policies assumption or policies assumption. These are policies. The policy that say these are your policies, 18 policy or dashboard you have for change. When you changed and you said, no, I make a mistake, up here you can reset them. Assumptions, I will go and say to you what is there. Here you have the graphs. These two graphs are their default graph, but they have another graphs. They have so many graphs in real. You see so many. We will work with some of them today. Up here you can change, or up here you can change the graphs. In view you have main graphs, as I said, these ones, or you have Kaya graphs. These are very important when you wrote an article or paper. I will say in the end of the workshop. Or you have miniature graphs, because in that time you have only 2 graphs. But here you have so many, and by clicking on them, it goes to be bigger showing for you. But here I said, okay, only main graphs. And you can change this one to which graph you need. And here you have the units. Here you have the play sound. Play sound helps you when you want to show something to people. For example, this one. And now here because we are in two different places online, I mute my device. If it was not muted, you can see both. With every click, you find the sound in your device. Here, the help, you have En-ROADS user guide. They have more than 300 pages booklet for helping you. They have support, some videos to share with you the information and other information too. And here, reset all policies and assumptions that we have here. But this one, you can do that. For example, you do all of this. By clicking this, all of them is going as the start. Here, they reset the graphs because maybe sometimes you change the graphs here. But the most important graphs are the beginning graphs. Because of that, with this one, you can do it. Here you have undo, but only for the last doing thing. Yes, for example, this one, this one, this one. This tool becoming to the starting point with one click, but this one is going by several times. In each click, only one term you're going to back. By this one, you go to like the words and another tools and softwares. This one doing only the last item. You see, it shows you what is the difference. You see, it is just to showing the people how they work affect the other one. Here you can make it, yes, full screen. And yes, and this one is for the miniature pictures that we had here too, but here we have them too. And here is help for you. And here is for sharing your scenario in Twitter, Facebook, LinkedIn, email, or copy link. You will do it today because in post-workshop, you have questions about what did you do in your simulation. Okay, I will go to our first step. I want to share with you. This is the workplace with this software or with this tool. They have the offline model too. You can download it, but the online is better to share and then others. First, to starting, come to see what we can do in the best way. You know, we can reduce the coal, reduce the oil usage, reduce the natural gas uses, reduce the bioenergy, increase the renewables, use the nuclear or deuse. What do you think? Yes, using nuclear is better. Net zero carbon price. You see, it is very important policy, carbon price. I will define more for you. In the transport, yes, we must increase energy efficiency. Electrification must be more. In the building and industry, energy efficiency too, electrification. Population must going down for better temperature. Economic growth must not increase, decrease. Maybe you think it must be increased, but no, because when your economic growing, your energy consumption, yes, because of that, you have more money to spend your energy. And like the rich countries now, your consumption is going up. Deforestation must be decreased. Methane and other gases, you know, the main thing that produce the methane is cow culture, natural gas, and drilling. I will say to you about these ones, their graph, this information, but just for your knowledge, yes. We must decrease methane. For afforestation, we must do our best. And for technological, yes, we must do our best. Okay, you see, these are the maximum things that we can do for the world. If we do this, yes, until 2100, or century 21 ending, yes, you see, we reached the 1.0 degrees Celsius. This is what is better than United Nations wants to us. As you remember, Professor presented you, United Nations said in the best way it will go to 1.5, and until 2 they accept, but it is 1. But it is the best way. I want to just show you, if you do the best ones, what can do you. But you know, it is impossible in the world. You decrease the coal, oil, natural gases to minimum and increase the energy efficiencies or afforestation or technologies to maximum, and population and economic growth to minimum. These are impossible in same time to doing all of this. But just for an example, yes, you can do this. Up here, it is very nice. You can see the description. You can see the UN and these ones. But most important, these ones of the graphs, you can copy data. When you prepare an article or another thing, you can go with this data to an Excel file. If now in some minutes it comes, my Excel, I will show you. Just copy up here the data, and you can paste in an Excel file. Yes, here you can paste. Yes, you can see. Now you have this data, and by this data you can prepare your own graphs for your papers. Because sometimes maybe you say this graph is not good for me, I want to change it. Just I do it for this graph too. Of these 3 dots, you come, copy data to clipboard, copy it, and come to your Excel file. In the Excel file, yes, just paste. Yes, you see. Of this data, you can get many graphs in Excel file and use in your papers, research, or another things. This is, and here you can see the UN, what they want and where are we are now. I hide it. Okay. These are the basic things I want to say to you, but I take it to the first step. Yes, you see, if we don't do anything and this situation remains until 2100, the temperature increased by 3.6 degrees Celsius, as you see here. This is the prediction of ENÇESU. Previously, in 2021, they said this is 4.1. But after they changed some equation and assumptions, now they said 3.6. You know, in research and scientific things, you can say, yes, I made a mistake. For example, it is not 4, it is 3.5. In policy, but you couldn't see that. You couldn't say that I made a mistake. Yes, here I want to show you, for example, I not this one full screen because I just want to show one slide. Yes, for example, you can see what is your actions effect on the climate change in the world. How? Yes, this model is world. But if you do something, you just think all people do the same. For example, you are going to be a vegetarian. If you are going to be a vegetarian, if you go to be a vegetarian and your friends, all the people in the world going to be this, you can see. If all of the people in the world going to be a vegetarian, this is an example just. Yes, in the transportation energy efficiency, it come plus 0.5%. So you can hear in transportation energy efficiency, we have more than this. Okay, so it is 1. And in the methane, about the methane, because we said the methane main resource is cow and this group. If all of the people in the world going to vegetarian, the methane in the world decrease 20%. So you can come to the methane and do it minus 20%. Yes. Yes. Now you can see the result. If all of the people in the world going to be a vegetarian and they don't eat the cow and another sheep and another things, yes, in the world you can see this change of 3.6 to 3.4. Yes, this is from an article, the result, and we did it in the model. You can do it for yourself too. For example, you say, instead of using my car, I use the public transportation. And you say, okay, now all of the people in the world, if do this, what happened for the world? These are the examples. You can do it for yourself. Here are some slides I want to share with you. Yes, for example, it is about the carbon dioxide removal methods. Yes, you can see what you can do. It shows in which dashboards, if you change something, it affects on CO2. For example, in afforestation, bioenergy, agriculture, enhanced mineralization, direct air capture. And I want to show you in this two slide why we must trust this model. You see, it is about the coal. You see here in the picture in right and up hand, the history of coal of 1992, 2015, of 2000 until 2100. You can see the baseline and how is it? Here you can see the most affected ones in the world. These are the models that world accepted, for example, from IPCC, from United Nations related organization or another scientific parts. Here you can see the carbon price test and others. But the important one is this one. Yes. As you see, for example, historical, and this is the En-ROADS. You see, it is very close, and En-ROADS cover the history data. So their calibration is okay. And now about the baseline, you see the different models from IPCC and another valuable models, and you see the En-ROADS cover all of them. Or about the carbon price test, you can see all the models in the right and down picture, and you can see the En-ROADS cover them in the average. So you can trust En-ROADS. Here we have some plenary rounds in workshops that people are in 5 groups and it is completely face-to-face. We do this. People coming to 4 or 5 member groups, and we do they model their actions in the En-ROADS model, and we going to see how they do it. But because this workshop is online and face-to-face, and it is hybrid, because of that I prefer to explain more about the model, and after that until 1 week you can go and see your model and do everything you want the model. Yes, here as I showed you, we have 18 dashboards of coal, oil, natural gases, and others. I will share with you this material. You can see what are they meaning. Their name is clear, but with the detail you can see with more details. After that, overall process, I said these are for the face-to-face workshops. We have 10 until 15 minutes rounds, 2 or 3 rounds, and after that we are going to what they do and what is the solution. But all of this in this workshop we are going ahead. What can you do? As I said, you are as a person in the center of the society. After that, you have private and personal, social network, organization, public, culture, and you have, in the end, the world. But as I said, when you do something, you can model it in the En-ROADS as you think all of the people in the world, if they do the same as you, what can achieve. After that, we have the multi-solving ones, but here I stop and I go to our model. In the end, I will come back to the multi-solving ones. Okay, here I want to share with you something. First of all, I want to talk about these 3 dots. These 3 dots may produce for you more detailed one. When you click on here, you can see something like this. For all of that, you have the same. Here, for example, they describe what effect on it, how is it going, how you can change it. Up here, you can do it as we do it for vegetarian people. Up here you see we do it manually and we don't know how we are changing it, but of 3 dots we can change it with very exactly. For example, from one article I wrote, it will be one action will affect 28%. We can enter here very exactly way. Up here you can change the use details things. When you click here, these are unlocked for you. You can change agriculture and waste emissions. Up here, energy and industry emissions. Up here, other greenhouse start. Start here is very important too. For example, you say I start this policy of now. Of 2023, it will be start. But in one another time, you say no. Especially, for example, for afforestation, for example. When you do something for afforestation, make some policies for afforestation, it makes, for example, here, 30 years for starting it. Or time to secure land for afforestation takes 10 years. But here you can change it. You said no, in one article or paper or report, I saw we have one type of tree that it takes only 1 year for time to do it. Or we have here not 30 years, we can start it with 10 years. Only every change you can do it here. And here you have graphs. You can change the graphs that you want to see. And here you have information. These are very important. Here you have the examples, how, for example, afforestation we can do. Here you have examples, big message, key dynamics. These are about the model. What is in the system dynamics, key dynamics for this component. Or here your potential co-benefits. And here is equality. As I said, I will come back to PowerPoint for multi-solving. In multi-solving, you see they are trying always to equality, to well-being in the world. Because of that, for every of these 18 dashboards, they have in the information equality consideration. For all of them, they have. When you change something for one dashboard, it comes blue, as you see, because it wants to show you that you changed something and don't forget it. Up here, I want to show you the assumption. As I promised you, I will talk about it. You can see climate systems. Everything here has some assumptions because this model wants to become popular, wants to become for everyone. Because of that, if you said, no, I don't believe this one, it must not be like that, you can go and change the assumption. For example, for frustration, I want to show you. Yes, frustration grow up time. 1 minute before everything, I want to change it as the first. Yes. Here, you can say, for example, frustration. Yes, their assumption is this. Frustration growth time is 8 years. But you can say, no, in one article I saw in 20 years with a special tree, we can frustration. Okay, it is 20. Or maximum available land for frustration in the world, they said 700 mega hectare. But you say, no, I wrote it can be 300 just. And after that, you say maximum carbon density. No, it is, I think it is 1. Or percent lose per year for frustration 2, or you can say, no, I think it is 4. You can change up here, and when you do it, the assumption if saved, yes, it became blue too because you do some assumption. And now, if I do something with frustration, it will be changed. First of all, I must do without any frustration. And if you change the frustration, maybe it changed too. Here you have some another assumptions, and you can go and change them. This model, as I said, it is related with CO2 permission and based in CO2 and energy. But for the another things, I want to show you the most important things. Yes, one another is graphs. If we reduce coal, oil, and natural gas and decrease these ones and these ones, I want to show you only the graphs. Yes, this is the graphs. You have the CN density of final energy, GDP, global population. You see, with these policies, you cannot change in GDP or population because they are relating with these ones. And you can change their settings of here too. For example, it says 2.5. You say, no, it is 5, or it is 3.6. You can see the change, what this GDP per person can affect, or another ones. Or here you can change the graph. This is the same graph. Here and here you have energy density. Yes, these are the graphs, miniature graphs you see here. And here I want to show one another important thing. Yes, you can see here I changed the coal, natural gases, bioenergy, carbon price, population, economic growth, electrification in both industry and transportation, deforestation, afforestation, technology. If you make attempts for the blue one, CH4 or methane, there is no change. What do you think? Why we have this? Can anybody answer? We have face-to-face more than 20 people here. Why it not changed, the blue one, methane. I changed all of the policies, not all of them, except one, and the methane didn't change. Why?
Because the blue one is essentially coming from the methane.
Yes, methane, and as we said, it only depends on cows and something like that. You know, in your energy supply, for example, fossil fuels, you don't have methane, you have CO2. Or in your transportation, industry, all of this decrease or increase the CO2 with your policies. The only thing that affect on the methane is this one, the cow agriculture and other things that are in this policy. By clicking in this, yes, you can see now the what happening. Yes, you see. Yes, these are important. These are important to make sure and be careful what policies you are doing for your problem. For example, for methane, you saw we did so many things and we didn't get any result because the special thing that affect on the methane was the cow agriculture and other things, not the transportation and others. These are important. Another thing I want to I want to show you at all is sea level impacts. Yes, in this impact you have so many good things. You can try them. But for example, here I show you the sea level rise. Yes, with these so many good policies here, as you see, the sea level very little change. Because you know why? Because the sea level increasing, doing so many things, as Professor presented in their slides, the carbonization, the emission of carbon dioxide in the world started from 200-300 years before, and it goes to rapidly now. Because of that, it is a long time period thing. With some policies in 100 years, we cannot say, yes, we solved the problem. They take time. Because of that, in some graphs, you see, with these policies, you have so many effects. For example, in energy-related things, you have so many effects. But for sea level rise, it is very little because, as I said, it takes time. And here you can see the delay. As I said, so many things in the real world has delay. Of today, if you make some policies to do and to get the world better, it takes time to get the effects of it. For example, you do something of today for the world, but sea level rise start from near the 2060, more than 40 years later. Yes, around 40 years later, it start to affect it. And up here, as I said, if you want to show it in your paper, you can copy this data and come here and paste here, and you can use them in your paper or another research methods. Another thing I want to show you, I want to go here and go here, is about the carbon price. I show you, be careful about this because we will see the change. About the coal, if I reduce it, you see what is the difference. 0.3 is the difference when I choose the coal. But I come here to the first step and I make the carbon price maximize. If it is maximized, you see the effect. 3.6 goes to 2.6. It is 1 degree Celsius is effect of this carbon price, and this one, as you remember, is 3. Yes, but now I said okay, it is maximized, 2.6, and it is minimized. Yes, what did happen? As you see, we expected because the coal was 0.3 and the carbon price effect was 1 degree Celsius. With both of them, it must become to 2.3, yes? Because as you see, if it is in 1 alone, it is 3 different, yes? 0.3. But when I maximize the carbon price and comes here, there is no effect on the reducers. Why? Anybody can say why? Why after carbon price maximize, the coal doesn't affect on this degrees Celsius? Why? Because when you maximize the carbon price, it is a very big policy. It is a very great policy. Because of that, when you maximize the carbon price, it affects the coal and other things, as you see here. It affects all of them. You have here the coal, and with carbon price, if you see this photo, with the carbon price maximized, the coal usage is going to down automatically. Yes, when you maximize the carbon price, the coal, automatically the use of coal reduce. So when it reduces, there is not different. As you see here, when I reduce the coal, there is no different here. So with the carbon price policy, we affect the coal too. And so when we decrease the coal usage, there is no difference here. But if we don't have this policy, with decreasing the coal, yes, you can see the effect of the decreasing of the coal is 0.3. These are the important things that you must see when you want to make some policies. There are some other things, but because of the time, I want to manage it. But I want to remain my this ones too, multi-solving. Multi-solving is very important thing in En-ROADS and in climate actions. Multi-solving as a verb, if we want to say, changing lives for the better while protecting the climate. Multi-solving is this: you make the climate, protect the climate, and changing lives to better or well-being. For example, this is a multi-solving. Burning less coal, the coal that we talk about it now. When you burning less coal, in short time, you have well-being or you have more health care. But in the long time, you have climate protection. So it is a multi-solving. You do something for well-being of the people and you do something for climate in the world. If you want to see how to group your works as a multi-solving, you have something like this. It is a flower, they said, a climate flower. You can see in the center you have climate protection and you have something to do. For example, if you do something for food and water, job and others, health, connection, energy industry, or resilience. And which one is related to your work, you can make it with color. For example, here they have a project, Walk to School outreach project. They said yes, as we did it for vegetarian people, they do it for their project. For example, they said instead of using buses and cars, if we walk to school, what is its efficiency? And it do something for transportation, energy efficiency. And you can do it for your self-works too. For example, now I will share with you ours. Here, for example, this is a project that me, Professor, and our friends have this project. This is the article of our project. We are doing it now with UN part, UNSTSN. For example, we said, yes, our project is a project about the walking instead of using cars and others, and it will be and because it used some intelligence, artificial intelligence and others, it can affect coal and renewable energy. These are the things that you can do for your own projects. Here you can see the health benefits for outweigh the cost of meeting climate change goals. Or here you can see the clean energy and health, what effect one project it affects on clean energy and health together. Or here you can see the clean energy and jobs. In the US, it takes more than 4.2 million jobs by 2030. Here you can see the health benefits of climate action. All of these are multi-solving because when you do something for climate, it affects on your health and other things too. It is not only one dimension and only doing only for climate. Here you can see, yes, it is about the publication because maybe some of you want to publication with this tool. About the conferences, you can just use this tool. For example, this is an article I wrote 2 years ago. Yes, it was the predicting climate change according to the conditions and practices of Iran and processing policies to improve the situation. We get some data from articles, reports, online websites about the 18 dashboards that we have. And after that, we put the data in the dashboards, in the En-ROADS, and we wrote the article. But if you want to use it for your journal papers, you can use it for calibration because this model is not new for your article. So you cannot use a tool for sending your paper to journals, but you can use it for calibration. Thank you until here, but we have 10 minutes. I want to show you some another details from En-ROADS because there's some more information things here.
Let's close the program. Let's say thank you
Okay,
for
John.
recording, and let's continue our job.
Make
Make a closing speech.
Okay, John. You don't want to share more?
No, we can share it.
Okay.
But no need to wait because of this ongoing program.
Okay.
Okay, say thank you, participation, or
Okay.
we can continue.
Okay.
Close the program
Tamam.
or television
Okay.
or
John.
YouTube.
I want to say that. Thank you so much for our university online participations and online assistance us. I want to say thank you for all of the participations here, face-to-face and online participations. We remain the program until 10-15 minutes. I will show you some more detailed tools from En-ROADS. But because we have the online part in the university website, we want to close it to not to take more time in our online programming university website. Because of that, I want to make thank you for Professor for sharing their information with us. Thank you for university's website protection to assist us to make it online on the university website. And yes, thank you so much. You can close the this program online, but we will remain in our Google Meet for our participations in Google Meet. because we will share with you. We have yes, because we have a post workshop questionnaire. I will share with you now the link. Because of that, you will remain in our Google Meet.
Okay.
Yes, hocam. Thank you so much.
Okay.
Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.